Live. There we go. All right, so today I want to talk real quickly again about graphing parabolas. Right? And hopefully we know what's the shape of a parabola. Give me a little visual.
A smiley or a frowny?
Frowny or smiley, yeah, one of those, right? So we all kind of know what a parabola looks like, right? So we got the general idea. Parabola is going to look, you know, something like that, right? Or it could be a frowny, right? You guys agree? Yes. So let's take a look at this example, okay? Let's graph f of x equals x squared minus 2x minus 8, okay? Now, one more time, I keep putting that darn f of x up there, right? But, you know, that f of x bothers you. But remember, let me real quickly ask a super easy question. Super easy. Is this a function?
Yes.
Yes.
So, I mean, I could write it like, I could go y equals x squared minus 2x minus 8, right? I could. You guys like y because the y-axis, y variables. But it is a function, right? So we're just going to say f of x. Now, if f of x bothers you, we'll say, okay, I don't like f of x, but I know, Zoe, I know that f of x and y are the same kind of thing, right? Yeah. So we can just change it to y, but f of x and y, most of the time, are going to be the same thing. Now, when it becomes something different, we'll get to pre-calculus when it no longer is a function, okay? But for right now, everything we are going to deal with are going to be functions, okay? Yeah, Aiden?
What would be a real-world example that would use f of x equals x squared minus 2x minus 8?
Can I give you a little slightly different one, okay? Okay, so right now, currently, North Korea would like to send a missile into the United States, right? What kind of shape do you think that path of that missile would be? Parabola. Can I stop there? That's a pretty good real-world example, right? Okay, moving on. Are you all right with that, Aiden?
That's why we should play World War II.
Right. Aiden, is that a good example? Sure. Okay. Anyway, so and they call them ICBMs because they're intercontinental ballistic missiles. They actually go out into space briefly, and then they come back in. During the Reagan era, they wanted to put big bombs up into space. This is real life, and basically, like take care of the missiles as they enter space. But then Russia got really nervous at that time and started bumping up their arsenal. So we didn't do it because we were afraid that Russia would then retaliate. Once we got our missiles up there, they'd be defenseless. So it never happened. Anyway, there's my real life application. Let's do this one, okay? So let's just graph this. So first of all, on last week, I think it must have been Wednesday or Tuesday, we actually talked about graphing. We talked about 4 different features, right? First feature, one, we talked about was going to be the line of symmetry. Okay? And we had a little mini equation. And we know the line of symmetry is the line that goes right down through the middle of the parabola. It cuts it down the middle because it's symmetrical, right? What's on one half can fold over to the other half, right? So then we have a little mini equation, x equals negative b over 2a, right? Remember that little equation? Okay, and then what we know in this is that a, b, and c are the numbers in front of x squared, x, and the number by itself. So in our case, our a is going to be 1, our b is going to be negative 2, and our c is negative 8. In fact, I'm going to write that down. We know a is 1 because it's a 1x squared. B is negative 2, and C is negative 8. Thumbs up? Thumbs up? Okay, does that make sense? It's just the numbers in front of x squared, x, and then our constant, okay? So now, let's use our little mini formula, okay? So mini formula, this is it. And somebody asked me the other day, well, what about the 2? The 2 is always there as part of the formula, right? We said that. The 2 is always there as part of the formula, okay? So the line of symmetry, let's go x equals negative. Well, let's see. We said b was a negative 2 over 2 because that's part of the formula times a, which is 1. Okay, now we just need to simplify this, all right? So I'm going to simplify that. 2 over 2, you guys positive 2 over 2, which is 1. So my line of symmetry is x equals 1. I'm going to circle that because I want to come back when I graph and use it. Yeah, Landon?
Why is the negative symbol before?
Oh, great question. So let me just do it this way, okay? Great question. Here's B, right? What did I put right in there?
That's a negative 2.
Negative 2. So I used parentheses to show that I put the negative 2 right there.
Oh,
And this negative...
because it's actually negative 2 in the equation.
Yes. Does that make sense? Okay,
So-
good. Yeah.
Does that mean that the numerator is always going to be negative?
No, not always, because if this were a positive number here, numerator, good word. If this were a positive number, we'd have a positive here, and then that would turn out to be negative, right?
Yeah. But then why didn't we just put negative 2 and why did we put an extra negative?
Where does this come from? That's the formula, right? So that negative is, Bijou, you see this negative? You'll actually do it this way. See this negative right there?
Yeah.
It's that negative, okay?
And it's always
And
going to be there.
it's always going to be there. And then this negative, right? Check it out. This negative is that negative right there, okay?
Okay.
And then I end up with 2 negatives, which makes it positive. Okay, good? Right, now, let's keep going. Now, we know the next thing we talked about, the second thing we talked about was the vertex, right? And what we said was, you know, the vertex at the very bottom or the very top, right? We know that line of symmetry has to go through the vertex, doesn't it? Has to. I mean, if this is my line of symmetry, it's got to go through the vertex because the vertex is at the very bottom or at the very top, right? So I already know something about the vertex. The vertex is, you ready? It's one something, right? It's one something because it's got to go through the line of symmetry. The line of symmetry goes through the vertex. But then the problem is the vertex is a point, right? It's a point, and every point has an x, y, right? Every point's got some x, y value. I need a point here. And to get my point, what am I going to do?
Plug and chug.
Plug and chug, right? So I'm going to take my 1, which is an x value. I'm going to put it into my original equation. So we're going to go y equals r1 squared minus 2 times r1 minus 8. Okay, slide up. How's that? And I'll erase this. Okay. So what I need is the corresponding y value. Zoe, just to give you something to think about, just to give you something, I could have done f of 1. There's that f of x thing, huh? I know, but it's one of those things you're going to see on that darn state test, and you're going to see it in some advanced math, aren't you? Right, Mr. Sofield? So let's plug and chug. Right? So we're going to get a 1 minus 2 minus 8. Agree? 1 squared, right? Which is a negative 9. So I have the corresponding y value for the 1, right? So the y value is negative 9, so my vertex is at 1 negative 9, okay? Circle that, okay? Good, because we're going to come back and do something with that later, okay? Third thing, remember we said we had 4 characteristics we're going to look at. So the third thing has to be my Y-intercept, okay? And the Y-intercept on this picture is actually right here. Let me draw a different picture so it looks a little differently. If I want to draw it differently, okay, give me a second. Boom, boom, and let's go like this. Okay, here's my Y-intercept, right? Great. Here's my Y-intercept. What is the x value at the Y-intercept? What's the x value?
0.
0. So a little rule I'd say if I want to find my Y-intercept, let's let...
X be 0.
Yeah, so x be 0. So let x equals 0. Good. And so if I plug and chug, but then I don't even know if I need to plug and chug. Let's check it out. Do I really need to plug and chug? What's the Y-intercept? Just like when we graph lines, right? The Y-intercept was this number by itself, right? Negative 8. But it does come from the fact that if you let x equal 0, you'd have y equals a 0 squared minus a 2 times a 0 minus 8. What do you, lo and behold, what do we get?
0.
And negative 8, right?
Oh.
Right? So it is also a point. Of course it's a point. It's right there. It's a point. So it has a coordinate. We know the x-coordinate because the x-coordinate's 0. So the y-intercept is at 0, negative 8. Okay? How am I doing?
Is this going to be mature?
Are you ready for an aha moment?
Wait,
No.
Yeah, we are recording, yes.
No, there's a 4.
Yes. Number 4. These.
X-intercepts.
X-intercepts. There's how many of them? 2. Most of the time. Not all the time. But for us, for right now, there are 2. I agree. So let me, again, easy question. What is the...
0.
Yes. Cosine of y value is 0. Thank you, Landon.
I feel like red.
You are just like red. No, you're not. So if I let, so x-intercepts, right? Let's let our y equal 0. Because again, at the x-intercepts, you're at the height of 0, right? That makes sense, right? And we should get 2 answers. So then what we're going to do, and I'm going to have to work up here because I'm running out of room. 0 equals x squared minus 2x minus 8. Okay, are you ready for a big moment? I am. So, I'm ready for a huge moment. So, how do you solve for x?
We do what we were. Oh, is it?
It's an F word. Say it. Refactor. Refactor. You're right. So why do we learn factoring? We are factoring because it's going to get us our x-intercepts. So we've been learning how to factor because it's going to help us get our x-intercepts. So exactly, I did that on purpose, didn't I? Didn't I? Of course. Do you think I did that on purpose, maybe?
Yeah.
I know. What do I know? X, right? Help me out. X, and then what?
Plus.
Plus
6
2
minus
Plus 2.
minus 4.
Now, okay, we're not done because what we have to do is still solve for x. Price, you're watching? We still are solving for x. Now the problem is, again, we said, it's so easy, we said there were 2 answers, right? So if we can find 2 mini equations, we could probably get 2 mini, like mini. So guess what? I want to know when x plus 2 equals 0, and I want to know when x minus 4 equals 0, and then I'm going to be able to get my x-intercepts. So, that's easy. So, minus 2, x equals negative 2. Do you agree?
Yeah.
Nope, sorry. Okay, and then my other little mini like little equation, plus 4, x equals 4. So,
Oh, those are our x-intercepts.
those are our x-intercepts. So, yeah. So now check it out. We can do this real quickly, but these, if I were to plug in 4, just honestly, if I were to plug in 4, guess what answer I'd get? Either one. If I plugged in 4, guess what I'd get for an answer?
0.
Yeah, you could try it if you want to. If I plugged in negative 2, guess what I'd get?
0.
Yeah, I mean, you could try it. If you want to try it, give it a try, but that's true. So these are my x-intercepts at negative 2, 0, right? And at 4, 0. I'm going to circle those, and then I'm going to start graphing. Yes. Bijou, question.
How do we do a continuous graphing? Like, how do we? So if those are just the points, what's our?
You are one step ahead of me.
Oh.
Hold that thought, because that's what I want to do next. Landon.
Okay, so on the line of symmetry, we only solve for x. Or do we solve for y?
Great, really good question. Now I want to take what both of you said and do it right now, okay? So let's graph, okay? So I know for sure I got to go all the way down to negative 9, agree? So when I make my graph, I'm going to go and try and squeeze it in here, but I'm going to go like something like this. Most of my information is on the lower part of the graph. I mean, if I look at all my points, most of my points from the vertex and my y-intercept are on the lower half of the graph. So I'm going to put my xy axis like this so I have room for everything, okay? Now, first, Bijou, okay? If I do my points, I should be able to sketch in a parabola, okay?
Yeah.
Second thing, Landon. So a line of symmetry is a line, right? It's not a point, it's a line. And we've talked about this before. What's the equation? Anybody remember? What's the equation of a vertical line? Anybody remember? X equals, what's our equation? X equals
0.
1, right? X equals 1. So let's just put that in first. Let's go x equals 1. And I like to make it a dashed line because it's actually not part of the graph. It's just the line of symmetry, right? So I just make a dashed line at x equals 1, right? Okay. So So it is a vertical line. It's not part of the graph. It's only a symmetry line. Now, Bijou, let's do what you said. Let's start plot some points, right? So my vertex is at 1, 2, 3, 4, 5, 6, 7, 8, 9, right? You agree?
Yeah.
And then I've got a y-intercept at 0, -8. 1, 2, 3, 4, 5, 6, 7, 8. How am I doing? Am I going too fast?
Yeah.
Okay. Well, you get this? You get this? Nice.
Oh, I don't understand.
Oh, and
Okay.
then
Right. We got a plan. We got a plan, right? Okay. Now we've got x-intercepts at -2, 0, and 1, 2, 3, 4, 0. Okay, how's that? Now, Bijou, I'm going to draw my curve real quickly because I know the shape, right? Everybody agree? We know the shape. So we're just going to go dot to dot, connect the dots, and we're going to put the graph in. But there's a magical hidden point that we could put down right now if we wanted to find it. Aiden, do you see another point we could put down?
Just like flip over the
Oh, yeah.
-8.
Yeah.
You guys agree?
Yeah.
Okay. Perfect. Can I say why?
Because it's like each side of the line of symmetry is the exact same.
Bam. Nicely said. It's a line of symmetry, so it's a reflection. It's a reflection of the line. Okay. Now, Bijou, we know the shape is, right? We know the general shape. So we just connect the dots. Yeah.
So I know where the -2 and the 0 came from and where the 4 and the 0 came from. But,
Just like
Right there.
practice.
No, but
On the
wait,
steps because this would take.
So
Okay.
then, is the vertex what we put right? Oh, okay, I see it.
Got it?
Yeah.
So let's remember, it's not pointy. It's going to have some curvature at the bottom, right? So let's just sketch it in.
Just sketch it.
Just sketch it. And
smiley face.
yeah, and we knew the general shape, didn't we? Right, Celeste? We knew it had to look like that. So if we connect our dots, it makes a nice parabola, okay? Okay, now, let me stop recording. I've got something else I want to show you, okay? And